Well, I just want to wrap up my adventure in hardening. So the first thing I did here with this A2 is I just cut a little piece off and hardened it to see if it would work, and it did pretty good. The next step was this guy here, which has 4 flutes, and the big issue with this guy was the diameter here. I think with all of them, I should have put the wire around the shank as well with the borax, because there is some oxidation, a lot more oxidation on the shank. But anyway, I made this guy here and ground it down. It did okay. It wasn't long enough from here to here to get the height that I needed for the dovetails that I wanted to cut. But it didn't break, so that was a good sign. The next one that I did is here, and you can see as I was trying to tap it around in the collet for grinding, I actually popped this tooth off, so these do have a bit of brittleness. This one came out okay. This had a little bit less diameter. I made a mistake in my cam, and I didn't get to use the full diameter of my stock. So I kind of used this one as a bit of an experiment. But since I was doing all the same setup, I did 2 at once this time. And when I put this in the chuck, the oxidation had it a little bit out of round. It didn't chuck up correctly. So anyway, I ground it. The flutes the flutes are a little bit off, but it cut okay. Didn't cut great. And then this is the other one that I did, which I fixed the cam when I put it on the lathe, and so I have the full distance here. And this is what I ended up using, and this worked out pretty well. The flutes are all about the same length, and you'll see in the video that this made a pretty good surface finish. When I cut these gullets in here, I actually put a vise inside of a vise to create this angle, and then put this in a collet block. So this one was cut at 90 degrees, so just straight across. This one I angled down a little bit and then cut straight across. So there's a little more material backing the tooth, and the gullet's not quite as deep. So if we compare this to an actual, professionally made dovetail cutter, this one's 55 degrees. You can see one of the big differences here is that there is a straight shoulder here, so that the transition, you can see this transition, there's a little bit of a curve here. And I probably should have done that, but I didn't. So anyway, I'll just show you the hardening and the grinding and some of the test cuts, and that'll wrap up my my first cutter experiment. Nice camera work. Here's the second one. It's interesting. There's this little green button of borax melted down in the hole there. This one seems harder than the first one. So now I'm a little worried the first one's not quite as hard, but this as hard as it should be. But this is actually the good one. So I'm glad I got it a little hotter. So I'm going to try to boil off some of the excess borax to see if that works, and then it's on to the heat treat. So I put them in some boiling water and hit them with a little bit of Scotch-Brite. So it's not all cleaned up, but the grinder will take care of the rest of it, I think. I didn't really scrub in here. You can see the areas where, like if I can get it to focus, like in here where these gullets are, it looks pretty decent. And then there's not a whole lot of oxidation on the cutting surface. the primary grind angle where that's going to be. So that's promising. I don't have a hardness tester. I'd test them, but I don't have one. So into the oven at 450 for an hour. These are thicker. I mean, quite a lot thicker. That's the comparison. So we'll do an hour and let them cool down and then do 500 degrees for an hour or two. So this is after the tempering. The geometry is a little bit different. I still have this little green borax gem in there. I wonder how long that'll hang around. There's quite a lot of oxidation on the shank here, and I'm a little worried that's going to affect the concentricity. I don't have any way to clamp it and then get it square and then resurface this. So if I were to do this again, I would try to address that. I'm just going to take some 320 sandpaper and try to even it out, and then use an indicator and make sure I get it in there square. You can see I got about 0.08 of a millimeter of run out. So I'm going to try to move it. Just rotate it around one tooth. See if I get a better concentricity. Some of that concentricity error is actually the oxidation on the shaft here. This is looking better. All right, I think I'm going to go with this. All right, so I got my stop set. My angle's okay. So we'll go ahead and do it. Hopefully it focuses. So spin it around. The last thing to do here is this this edge, which is real hard to get. So I'm just going to do that by hand. I didn't put any, I just put a little angle that way on the tips, like 2 or 3 degrees. I didn't put any back angle, so I probably should have, but we'll see how it cuts. All right, back at the mill. Fire it up. More speed. Oh, it cuts much better. I think so. Oh yeah, that's the one. So, you know, it's not perfect, but feels nice and smooth. That doesn't look great. Probably regrind the bottom of the cutter a little bit. This is for this is the this was the semi-junky one for comparison, so you can definitely see some lines and striations. This also has some of that, but it's not too bad. Yeah, let's see what the depth of cut is. About 6 millimeters. So that's good. I think I needed 8. I don't know if I can get 8 out of it, but I definitely have a better chance with that one than the other one. Yeah, this is what it looks like after the cut. I didn't grind the bottom here, so that's just rubbing. And I did hit this surface. Come on, focus. I did hit this surface here, but it's real hard to get in there. And maybe I didn't hit that. It doesn't actually look like I did. Maybe I didn't. I thought I did, though. You can see the difference in the tooth widths. So this one's, it's got some issues. But this one came out better. I think it's because I gave the shaft, like I just stuck that in there right out of the tempering. And if I were to really make a tool out of this, I would try to figure out a way to cylindrically put this on a cylindrical grinder before I chucked it up in the tool and cutter grinder, because this surface, I didn't have the wire wrapped around it, and there's quite a bit of oxidation. All right, so here's my piece. We're gonna put the dovetail on. This was one of my first cutter grinding experiments, and I didn't relieve the middle of the cutter, and it made this cool pattern. I kind of like it a lot, but I'm gonna face that off, and then we'll rough this in for the dovetailing operation. So there's a ridge here, and that's from the rubbing of the cutter pushing the material up. You can probably see it back here. Right along this edge here is where the rubbing is. So I'm just gonna hit it with a file, take some material away, and then do a final pass. I'm 1/100 of a millimeter under the number I wanted to hit, so it's gonna be a little under, but it doesn't matter at all. There's a couple problems here. On the first cut, there's a flat right here, and that allowed the cutter to get the full depth of cut without rubbing. On this side, I had to take all the material away, and so it was rubbing, it was pushing up a burr, and then the cutter was actually tilting over, which caused a step in here, if you can hear that or see that. There's another step here because I don't think I had it quite tapped down in the vise right. I didn't move the quill at all. So in order to fix this, I'm just going to take a little bit of this material off here and a little bit of this material off here, make a square cut, and then try to do one final cleanup pass to get all this on the same plane. Surface finish looks really quite good, other than the rubbing issue. Focusing doesn't look great. So you can see it's quite reflective. It's a good surface finish all the way around. So anyway, I'm going to throw it in the other mill, take that off, get it in here, try to actually get it square in the vise, and then do a final pass all the way around. It will be a little bit under dimension, but it doesn't really matter. The step doesn't really matter either, but I'm just going to clean it up for practice sake. This last pass was a regular conventional cut, and I think this last pass was a climb cut. Highly reflective. I'd say that looks really fantastic. Some little scratchies on the floor here, no big deal. And not as good of a surface finish on the conventional cut. Right, here it is in the device. And just turn this a little bit, cranky that in. It's not going anywhere. So that's it. First dovetail. I don't know which way to put it. I know that's my gib on the ground, which is no good. The angle looks good. Yeah, so just like a quarter turn, good sliding fit. Quarter turn, if it would focus. Locked in, half turn, not going anywhere. I gotta cut slots in for the lathe tools. I don't know whether I'm gonna cut 2 slots or 1. Little 1/4 inch jobbies. I'm gonna cut a slot kind of close to the edge and then put some grub screws in. And that'll let me hold and grind lathe tools. So that's it, all that work to do this, which is not even really necessarily a critical fit. But I learned a lot, but I'll be able to use the cutter on this, which was cut at 55 degrees and needs to be recut to 60. This is my tapered gib saddle experiment for the mini lathe. So that's gonna go, it's gonna be mounted on here. And I have to remake the taper, which I've already done a couple times. And that has to also be cut to 60 degrees. So there was a reason I made the cutter other than the lathe tool holder on the grinder. And that'll be one of the next things, although I feel like I need to do something more creative and maybe dig into my scrap pile and get rid of some stuff. So that's it. Thanks for watching. And if you have any questions, leave them down below. And if you want to please the algorithm, hit the like button. Thanks.